Okay, we have covered data manipulation language, which includes select, insert, update, and delete. We have also briefly introduced create statement, which is part of the data definition language. We call it DDL. Let me set this up a little bit. I'm going to use the laser pointer. And the DDL define the database schema. The schema is equivalent if we say database, which is the metadata of a database, the structure of database. It's not the actual data that you will store in the database. And so the key statement in DDL will be the create statement, such as create table, alter statement, alter table, dropping a table altogether, including its data, and truncate will clean up the data in the table, but not deleting the table. So instead of saying delete a row, for table, we use the drop verb for deleting a table altogether. And why DDL is important? Because in DDL, we can enforce data integrity when we define a table. We can also create indexes which will speed up our search performance. And the data integrity will be enforced by various constraints. We call it rule or business rule here. So how do we do it? Through those statements we mentioned earlier, create a new table. We use the create statement, which we define the table. We can change existing table using alter statement. And then, as we mentioned, truncate and drop is to delete a table. If you delete all the table's data, you can use truncate. And certainly you can use delete statement, a data manipulation language statement. Drop is just dropping the table, and all the existing data in the table will be cleaned up. So let's look at what kind of database object that DDL deal with. Database itself, which is the whole thing. And the main object certainly within the database is table. And we learned a little bit about view, which is a virtual table defined based on a select statement from existing tables or view. Index will speed up our search speed in select statement. Constraint is to enforce data integrity, including foreign key, primary key relationship defined as a constraint. And there are other constraints as well. So here, the operation, as we mentioned earlier, like create, alter, drop, or rename, like rename a table name. The syntax which we introduced later, create table and the table name, and then start defining the column, the data type for each of the column, etc. We can alter table here, like student table, by adding new column. Let's say an email column, define its data type such that it can be up to 11 characters in length. We can drop a table. Just say drop table and the table name, then you're dropping the table. Okay. So those operations typically apply to this database object over here. If we look at in MySQL Workbench, such as our class schema or class database, this is the database itself. Then we have a bunch of table like course, division, instructor, etc. We can certainly look at the column within a table and the index we created based on certain column in the table. And we can also define foreign key. Triggers more advanced, we're not going to discuss it. And also we can look at the views under a class schema or class database, our class database. So that's basically what we can do, and we're going to show you how to use MySQL Workbench for doing performing operation related to DDL. So we can create table, create database, create table, create view, create index, and we can particularly alter an existing table, including create or drop unique index, primary key, and foreign key. And we can also define additional constraint. Okay? When you create a table in its primary key, index will be created automatically for the primary key column, and that index will be a unique index, which means that the value for that index column should be unique. You cannot have duplicated value. Foreign key, the index is created automatically on the foreign key column, but foreign keys is not a unique index, okay, unless you specify. Typically, it's not unique. For unique key, which means if you define a column and say it has to have unique value, then it's indexed automatically, and that's unique index. Okay, this is a little bit advanced, but just introduce it to you. You can drop table, drop database altogether. Don't do that without double check. You can drop the table, including the data, and the index built on that table will be dropped. Okay. You can drop view, so the view can be certainly removed. You can rename a table. This is the syntax for renaming table. Rename table, the old table name to the new table name. Okay. So for you can use drop index to drop normal index, unique index, but you cannot drop index of the primary key and foreign key. You actually need to use alter table statement to drop the primary key and then to drop the foreign key, and then the corresponding indexes will be removed. So this is how you can look at the structure of a table. Here we select the division table, and then you can look at the column within the division table, specify its data type, and whether this column is a primary key, and whether it's not null, and whether it's unique. And here are those acronyms. You can find the corresponding meaning of those acronyms over here. Okay. So this is in SQL Workbench, and let's look at it in MySQL. Okay, I'll show you. We have our class database. Double click, make sure it's expanded. Then we saw those table name. We can look at existing tables definition by clicking this wrench. Okay, so this is what we have seen in the PowerPoint slide, and we can certainly add additional column or deleting the column through this SQL Workbench interface. Okay. We're going to create a new table And in this new table, we're going to introduce um, another feature in a table's column, particular primary key. Here, we're creating a table which is an employee table. ID is the employee ID. We define it as an integer. And we also specify its auto increment. Auto increment means that when we create a new employee role, we don't have to specify employee ID. The system would automatically assign a sequence number, a sequential number. So we started with employee number 1, employee number 2, etc. And the employee has name and has title, and we specify it's not null, and we also specify this employee ID column is the primary key. It is possible when you insert a row to this particular employee table, you can assign an employee ID, an integer, but it is not recommended. You should let the auto increment to automatically assign an integer sequential number to this new employee. So let's see how we can define it, such as here. I'm going to do it live in MySQL Workbench. So I'm here in MySQL Workbench. If you click right mouse button here in this table area, and we have create table. Okay, let me just select the database name. If you select database name, you do not see create table. You can create schema, a new database, alter, maybe changing the existing database name, or drop the whole schema. Don't do that, by the way. Okay, then you're going to drop it. Okay, so it's important for the right mouse button click pop-up menu. You click, you highlight the table, click right mouse button, and say create table. This is how you can create a new table to an existing database or database schema. So we're going to say employee. I prefer to use singular form. Column name, let me use, just click on it. I'm going to say ID, integer, primary key. Primary key. By default, if it's primary key, it's not null. And we have that auto increment. AI actually means auto increment, not artificial intelligence. We have employee name. I'm going to say name. Bar chart, I believe that's tab. I'm going to select 20. And title. Push the tab key. And 50. Okay. Let's say it's not null. Okay. And if you so that's pretty much it. Okay, regarding the creation of this employee table. And so if you close this, the table will not be created. Okay, you have to come here and click apply. Okay, so let's do apply. This is the create statement that if you apply again, it will be executed. It will be run. It will be running the SQL script, which will create actually the database table. So let me just copy it. For some of your assignment, you need to show the create table statement or insert statement, and sometimes you're going to see this. So I'm going to make a copy, and let me just say apply. I already used Control-C to copy it. Now I'm applying the SQL create statement, and so I'm done. Okay. They say apply changes to employee, so we made that changes. Let me just keep open a blank SQL script editor tab. Let me just paste what we have earlier so we can see it more clearly. Create table, class dot employee. And by the way, technically, if this is your default database, class database, you don't really need this. You don't really need the single quote, okay, unless the column name or table name is a reserved word. Then you need it. Okay, I usually prefer to see a simplified version. Okay, so in this case, ID is integer, data type, it's not null, it's auto increment. And you can say primary key here, like primary key, but here, alternatively, you can just define ID as a primary key, which is probably a more explicit way of defining the primary key. So I will keep it this way. And let's try this. If you click execute the statement, watch here, okay, we have 1, 2. They're going to give you an error message and say create table employee, error code, table employee already exists. So unless I can actually technically delete that employee table, which is here. By the way, in this case, doesn't seem I need to refresh the database. The employee table show up. Okay. If somehow you delete the employee table, if you have this create statement, you can run it and get it back. Okay. Why don't we do that? I'm here. I can drop the table. You see, drop, create, alter, and drop. Those are the DDL related to table. I'm going to drop the table. Drop now. Okay. So the drop has been executed. Let me just use this create statement, which I copied during the previous step. Let me run it. So it worked, 0 row detected. Because I'm just creating a table, it will be an empty table. And here, the employee table is nowhere to be found. And this is where I need to say refresh. Now I got the employee table. Okay. If you want to look at the table definition, click on this range. We kind of get back the table definition form here. Okay. Let me close it. If you, let's say, click on the table data icon, the third icon, you find out that I select everything from the employee table. By the way, this I don't really need class because this is a default database. And there's nothing in here. The asterisk just means a new row if you want to create a new row. So why don't we do that? Since this I use auto increment, so I'm not going to enter an ID. Okay, I'm going to let the system automatically assign a sequential number for me. So the name, I'm going to just keep it simple. That's Minder. And then I say the name and another name. I'm going to say Justin. And then instructor in terms of the title. Okay. So I'm done with entering 2 row. Okay. However, this 2 row will not be safe until you say apply. Until you click apply button here, down here. So let's do that. Okay. Once again, particularly for your database assignment, which may require you to write insert statement to enter new row in a table. If somehow you did it this way, and then you want to kind of use the insert statement generated in this process to write the insert statement without writing it, then you copy it. I'm going to say apply. Okay, make sure it's done properly. And then I'm going to say finish. Okay. Let's see. Supposedly, why don't we click away from it and come back and click again. Yeah, we saw there's 2 new employee. And by the way, I didn't enter employee number 1, number 2. The 1 and 2 were created during that insert operation through that auto increment. Okay. Let's just use this. Okay. If you let's look at the 2 insert statement. Let me just clean it up a little bit. I insert into the employee table. Let's look at it with the name, not the ID column, name and title column. Okay, and the value is Minder, and the title corresponding to the dean is the value corresponding to the title. So this is just insert a new row. And by the way, I kind of hate to do this, but let's do it anyway. If I execute this insert statement, guess what? I give you a few seconds to think about it. Would I be successful in inserting it, or would I fail? Let's try and I'll explain. Okay. We can look at, by the way, there's 2, let's just execute. We should execute the statement under the keyboard cursor. So only this statement will be executed. So 1 row affected. Okay, let's come here. Okay. And obviously, this is not good because I have the same person Minder as a dean and show up twice. The reason the system allow me to do it because they automatically create an auto increment, create the employee ID 3. That's the primary key. And 3 is not a duplicate value as a primary key because we have 1 and 2, they create 3. We're not checking whether the name is unique. We're not reinforce that, and certainly we're not reinforcing the title. So that's something. If somehow we enter the employee ID and in the insert statement, and by the way, Although auto increment will not recommend you enter the ID, but in MySQL you're allowed to do so. So let me just say 1. Okay, employee ID 1. Let's say I want to change vendor, not changing. Let's say I just want to insert this. Okay, let's see what happens. I think system won't do it because they detect you already have employee number 1. So you got an error message. Insert, okay. Duplicate entry 1 for key, primary key of the employee already exists. The error message is not very clear, but that's basically what it meant. Okay. And that's the insert statement. So so this is what we have. Okay. Let me show you a few more things. So you're using the employee table we just created. If you click right mouse button on top of a particular table, employee table in this case, there is a function in the pop-up menu called send to SQL editor. Okay, which means they can generate some SQL statement, including select, insert, update, delete, the DML statement, the 4 DML statement for you, and also the create statement. Let's try create statement first. Okay. This could be helpful if you forgot during you define the database in the let's say over here, and you say apply, and you forgot to capture that create statement. Then hold on a second, and then you can recreate it here without redefine it. Okay. And so table employee, okay, pretty much the same. This part you don't really need it. That's kind of a very physical level about MySQL server. You can remove it, which doesn't change the fact that this is a correct create statement. So this is just the create statement. We can also click right mouse button again. Let's try the insert statement. Okay, send SQL editor, insert statement. So here we got insert into employee table, and then ID, name, title, and this they're not creating the exact insert statement that we for the existing data. This is for new data, and you need to be aware. And since this is auto increment for the ID, you probably don't need this. Okay, and then you need to enter the name. For instance, I'm going to say test. Okay, for the name, and for the title, I'm going to just say director. So that will be an example of the insert statement using the template generated by by that feature I just mentioned. Let's see, something was wrong. Insert into employee, name, value. I didn't see anything wrong here. Let's say value. That's weird. Okay. That's red stuff. Okay, indicating inserts not a valid in this position. Oh, I see. I know what's wrong. They complain. This little squiggle underline insert. If you come here, they kind of show you the error message. Insert is not a valid at this position, expecting end of file or semicolon. And actually, our SQL statement is correct here. It's actually, since we have more than one SQL statement, so the create statement, the first one we have, we need to end it with a semicolon. Okay, now this is correct. Now we can put the cursor anywhere inside the statement and just click this particular. They say execute the statement under the keyboard cursor. Okay, so I'm going to just, so it's done properly. We can come here and look at the table data. Now that's been inserted. Okay. So far the demo conclude basically how you create table, how you insert data into a new table, and how you use the create statement and the insert statement. And so let's move on. Okay, so this is the example and the demo we just did. Okay, pretty much the same one. And this is just remind you when you use this form to create new data, then you need to say apply. And when you click, you need to click apply here first. And then the insert statement will be displayed. And when you say apply, then this insert statement will be executed. Okay, you may want to copy this insert statement. So let's discuss how to create relationship through foreign key, primary key pair. This is the most important thing for a relational database. That's where the power of relational database comes from. We actually discussed this previously, but now since we're familiar with the create statement, and let's look at it again. We create a parent table. We just call it parent table. We has a single column, which is integer, not null, and it is a primary key. The ID is a primary key, so it looks like this. Okay. And we create another table called child table, which also has an ID here. And we create another column, which is called parent ID. Without a better term, we call it parent ID. And we create an index. We just call it parent index. This name can be anything as long as it's a legal name in SQL statement. So basically, we kind of saying that this this parent ID is indexed. Okay, this parent ID is indexed. Okay, and then we specify foreign key. Okay, this is new. The foreign key, okay, is the parent ID, which means we say, hey, parent ID is a foreign key. Over here, it's a foreign key. It referenced the parent table. This parent is the parent table, the name of this table. The ID is referred to this ID, not this ID. Okay, I happen to use ID for both parent and child, but here the ID is the column name in the parent table where it's used as a primary key. Okay, on delete cascade. What does that mean? On delete cascade, which means if I delete a parent table entry, then all the child row, which with the primary key value of that entry, will be removed. Okay, for instance, if you delete a department and then all the employee in that department will be deleted if you specify on delete cascade. cascade is actually a row delete in the parent table, and all the corresponding value of the primary key value in the child table will be removed. Okay. This is the relationship visually in SQL Workbench data modeling tool, which we're not really introducing the data modeling tool in this class, and at least not in this lecture. And we use the crop foot notation. This is the crop foot, which means one to many. We call it one to many, one colon M, one to many. And the one is on the parent side, and the many, the crop foot notation is on the child table side. Okay. And there's really two symbols, the crop foot and then a kind of horizontal bar. It could be a vertical bar, depends how you draw the diagram. The one at the outside, and that actually means one and only one. This means one and many. And this is what we refer to as cardinality of a relationship. Cardinality or multiplicity of a relationship. Okay. So to build a relationship, we have a column in the child table, create a column in the child table where it serves as a foreign key, where it is a foreign key. The foreign key pointing back or reference the parent table where it serves as a primary key. Okay. So this is important at a very detailed level. This is how we define a foreign key primary key pair. This is the foreign key column in the child table. This is the primary key column in the parent table. The ID is the primary key column in the parent table. Okay. So once you know that, then the following few slides are pretty much just explain that. In the MySQL Workbench in data modeling, if you click on a relationship, they will highlight the foreign key primary key pair. For instance, they say, hey, the D_ID is the primary key of the division table, which is the parent table, as we discussed earlier, has a child table where div is a foreign key that reference back to the division table where it serves as a primary key. So in this case, div just means which division the instructor works for. Okay, and this is where we define the constraint. We have a foreign key. This is a name of the foreign key. You can specify. You can give a foreign key constraint a name. Here we did not specify the name, but it's a good idea to give it a name. Okay, foreign key is div, so div here is a foreign key. It reference pointing to the parent table division table. That's the division table. It's primary key where this foreign key column div is used as a primary key. So that's how we define a foreign key. Okay, and this is how we define the primary key. In the instructor table, I_number is the primary key. Okay. Same thing here. We can specify foreign key primary key pair, and this is how we define it. Okay. And by the way, if you want to actually look at this data model in your Northwind database, you can click on the link here and then load it up. I'll show you just briefly. In MySQL Workbench, typically we're here. Okay, if you this is the database, and typically would use this feature. But if you so eventually you're going to load all your database whatsoever, but you can click this home icon and click this data model. You can open a data model. If you click that link I mentioned earlier and download it, let's look at the download folder. We found you should find a Northwind underscore v2 dot model for Workbench, for MySQL Workbench. Okay, you open it up. Eventually, you're going to see this one. Okay, this this contains actually several data model: Northwind database data model and class database data model. Okay, and the class model actually is here. Okay, let's briefly. This is what I meant. If you move your mouse, hover over this line or click on it. Okay, you have to, and you will see the corresponding foreign key primary key pair being highlighted. Okay, that's highlight. In this case, primary key foreign key consists of two columns, more than one column. This is student number. This is course ID and offering number. Okay. And by the way, the notation here, if you look at two key, okay, that means the two key together serve as a primary key. Okay. And let's see what else we have. Yes. Okay. So just very briefly, this is the data model, as we call it, data model. It's actually called extended ER diagram, and sometimes I just call it ER diagram with this cross-foot notation for one-to-many. You can tell actually most of the relationship, actually all of the relationship are one-to-many relationship. This is just the another foreign key between offering and courses. Okay. In registration, we have seen earlier, this 2 is the primary key in the offering table, and they are foreign key here. In this registration table, actually the student number combined with course ID and offering number, the 3 together is a primary key for the registration table, and which is we call it associated entity type or bridge table, which capture the students' enrollment in a course offering. Okay, so it's a little bit complicated. But if you understand foreign key, primary key, you can kind of read the statement here. Registration actually has this 2 as a foreign key, and the student number is also a foreign key, which is used as a primary key in the student table. But the 3 together is the primary key for the registration table. Okay, constraint registration's primary key, which is a primary key constraint, include course ID, offering number, and student number. Okay. You can specify the data type, bar chart, small integers, and you can specify constraint. Somehow in Workbench, there's no easy way to enter the constraint itself, so you actually have to do it in SQL code. If you specify this student number earlier defined the student table without defining this check constraint, which means student number, which is a small integer, has to be greater than 0. You can write an alter table statement, say student, which is the table, add constraint, and this is the name of the constraint, student number 0, which doesn't have any enforcement power. But this check, student number greater than 0, does check this rule, which means if you enter a student number which is a negative number, they're going to kick you out. They're not going to let you insert that student's record. Okay. So let's try to create relationship visually or using the tool without writing the create statement or alter statement directly. If we look at our instructor table and division table, you realize that in the division table, I have a column called DIR, which is director. Who is the director of a division, okay, of this division? And the director has to be someone in our instructor table. So director is a foreign key where it referenced or pointing to the instructor table where it serves as a primary key. So just keep this in mind. We need to define dir as a foreign key. Okay. How do we do that? In the table definition tool in MySQL Server. So let's come back here. I got the division. Let me use this wrench icon, which is a table definition. Okay. And this dir, there's nowhere over here that we can specify that's a foreign key. Okay. We can specify certain columns a primary key, but there's no selection for foreign key. So what should we do? We will come here and say foreign key. Okay, you need to be very careful in following the procedure here. And the foreign key name, I'm going to say director foreign key. Okay, that's just a name. Come back here and to click on this referenced table. Okay. Hold on a second. Reference table. Okay. Where reference the instructor table. Okay. We reference the instructor table, and then which one is the foreign key? You need to say. So remember we're in the division table, which is only 3 columns. Okay. We're defining foreign key. So we're selecting like, oh, dir is a foreign key. Okay. But it's referenced, okay, the instructor table. Okay. Here, the system asks us like, so which column are you pointing to? Okay. Actually, I prefer to use reference instead of referenced. Okay. So we reference instructor number where it is used as a primary key. So once again, give the foreign key a name. Specify the parent table, which is a parent table. Yes, parent table. In this case, instructor can be the director of more than one department. Our sample data set actually has that scenario. So the reference table, okay, is the parents table. The division is actually the child table. Okay, so dir is a foreign key pointing to the reference table where it serves as a primary key. So you have to specify which column that you reference to. It doesn't have to be primary key. As long as that column has the same definition, same data type, then potentially you can still build a foreign key. But in almost all, most of the case, if not all cases, that reference column will be the primary key for that reference table. So we're done. Don't take any action because if you try to enforce some data referential integrity, like restrict, cascade, set null, it may not work because we have some data already exist in the truth table. Try to enforce the data integrity. Certainly, it's a really good idea, but our existing data may violate that referential integrity rule. So we shouldn't take any action at this point until we make sure that the data is in our database conform to that data integrity referential integrity rule before you turn on those on delete or on update enforcement. Okay, so we haven't created the foreign key. We have to say apply. The system would generate the SQL statement. I copied it. Okay, to create this foreign key. To say apply. Okay, if you create a new table and when you create the table, you define the foreign key and then you apply, in that case, it will be specified in that single create statement, okay, instead of the alter statement. So we're done. Okay, I think it's okay. Green light. Let's look at it here. So alter division table, foreign key will be indexed automatically. We're alter the division table. We add a constraint, which is a foreign key constraint. The foreign key is the dir column that reference the instructor table where corresponding to the instructor number where it serves as a primary key. There's no action for on delete or on update. Okay, so we're pretty good. So if we let me have some space. If we click right mouse button here and send to SQL editor, let's choose the create statement. Okay, you will find the foreign key constraint here in the single create statement, along with other things which define the table in the first place. Okay, and the reason earlier we did this because I created a table already, and then define that foreign key after the table has been created. So we have to use this alter table statement. Okay. Hopefully that helps you to learn how to create relationship without using the define the constraint of the foreign key. And you can do it in this table definition form over here. Okay. Just very quickly, I think we have done demo and explain view. You can create a view and view as, and usually it's a select statement. So you can define a view, give it a name based on a select statement. So in this case, we will select all the instructor whose title is teacher. We'll only have two, so eventually this teacher view at least based on this sample data set, we'll have 2 teachers in this view. Okay, but this may change because if you change the underlying instructor table by adding new teacher, new instructor with title called teacher, then when you refer to the view or query the view, you're going to get more than 2 instructors who are teacher. Okay. So let's look at it. So we can, if we query that view, okay, I usually call it query the query. I like it, okay, because view is really defined based on a select statement. That's a query. So if you say select everything from the teacher view, okay, from table or from view, can be from view, where salary is greater equal to 50K, okay, we have 2 teachers, but only Albert Stone on salary is more than 50K. So this will be returned. Okay. Internally, the database is smart enough to combine the query definition, like in the previous slide, the query definition here, the select statement here, and then the select statement here, and formulate a select statement. Okay, make sure they are based on the view. The title has to be teacher. Okay, and then the condition, which is the new query against the view, will be added. Combine these 2. Okay. View can be very useful. We use view sometimes to find a view, and then, for instance, if somehow some people need to have access to the employee table or instructor table, but we don't want them to see the salary information, we can create a view without the salary column and only give those individuals who can and want to view the employee data without the salary, and give them access to the view, but not the base table which contains the salary. So that's just one common reason for us to create view. Okay. So when you create a view, we're saving the select statements definition for the view. We're not saving the actual data. So view can be considered a virtual table or derived table. And the actual table, we call it base table, which contain data. Okay. So you can define a subset of a single table when you create a view. You can combine data from more than 2 or more table or view. And the table certainly is called base table. There's some restriction. You cannot use order by or union in the definition of a view. View is read-only if its definition involves a join statement, a distinct keyword, group by heading, or function. Okay, read-only, which means you can only use select statement, select from a view. It is possible to insert, update, and delete a view. I don't particularly like it, but it's possible. However, if you define a view with join, distinct, group by, or having, or some function, then you cannot do insert, update, delete against a view. Okay. So this is just back out a little bit. In the select statement, we can select from tables. We can also select from view. Okay. When we do join, we can join several tables. We can also join table with view or view with view. Okay, based on some join condition. So just from the select statement's viewpoint, they can select from table, they can select from view. Okay. uh, in most of the case. So assuming a view is specified based on the base table, so you can select from view. Basically, you're selecting from those shaded area from the view. You can update, delete, and insert. Then the underlying base table corresponding row or column would be updated. Same thing for delete. And for insert, for instance, the third column, if it's null or default value, you can insert. And then this one, I don't know the value because you insert into this view, which does not include this third column. And then as long as this third column allows null value or has a default value, then we're fine. We just assign a null value or the default value of the underlying base table. Okay. Let's finish and just discuss index. Index, which means we've seen the creation of index. When you create index over a particular column in a particular table, you can also specify whether it's ascending order or descending order in terms of that index column. And it can be unique or can be non-unique index. Primary key, then its index is unique. Okay. Foreign key, not necessarily. Okay. So why we need index? Index allow you to retrieve data much faster. Index allow you to perform certain select statement, particularly when you use those indexed column in the where clause or as a join condition. They will perform that much faster. So so that sounds good, right? Why don't we just index a lot of columns as we wish? Because they do speed up the data retrieval speed, fast data retrieval in terms of select statement. The trade-off, the downside is that when you index lots of columns, your performance during update, insert, update, delete will deteriorate, will slow down. Okay, so you need to consider this trade-off: fast retrieval, slower update speed, which is insert, update, and delete, or faster insert, update, delete, and then slow down in terms of data retrieval. So find the right balance. Depends on the usage pattern. Okay, so just remember, index is related to primarily data retrieval performance. If you do create index on certain column that's used for foreign key or for certain select statements, search criteria, it improves the retrieval speed dramatically. Okay. So we explained data manipulation language to begin with: select, insert, update, delete. We finished just now the data definition language on creating table, alter table, and create view, create index, etc. The two other languages we're not going to discuss is the data control language, grant and revoke, which is managing security of the database user, and the transaction control language. Some people consider that's data control language. That involve commit and rollback, which is for transaction processing, try to ensure data integrity for transaction processing. So that's pretty much it. We're kind of done with the SQL lecture series. So thank you for listening, and I'll see you again for some other topic.